You know, every single time you use your phone, making a call, sending a text, whatever, it's actually taking part in this invisible, super high-speed race. Seriously, it's a race against thousands of other phones, and the finish line is the cell tower. So today, we're going to pull back the curtain on the secret sauce that makes it all work. A little something called timing advance.
I mean, think about it. You're at a packed concert, thousands of people are all on their phones. How does the network not just, completely fall apart? How do all those signals not just smash into each other and create one giant garbled mess? Well, the answer is this incredibly clever system of tiny, microscopic adjustments.
All right, so first up, the race against time. The core of the problem here is a basic law of physics you learned in school. The speed of light is constant. And because of that, every phone signal is in a race to get to the tower. But here's the catch. They're all starting from different places, and that creates a huge headache.
Let's just picture two phones to make this super simple. Okay, so one phone is right down the block from the cell tower, maybe 100 meters away. Its signal gets there almost instantly. But then you've got another phone way across town, a full 10 kilometers out. Well, its signal's got a much longer trip, so it's naturally going to take more time to arrive.
So here's the real kicker. If both of those phones just decided to send their signals whenever they felt like it, their messages would hit the tower at slightly different moments. And we're talking about a delay of just microseconds. But for the super sensitive gear in that tower, that's enough to cause absolute chaos.
And yep, that chaos has a technical name. It's called intersymbol interference, or ISI for short. The best way to get your head around it is to just imagine two people trying to talk to you at the exact same time. You can't understand what either one is saying, right? It's just noise. For a cell tower, ISI is exactly that. Your data gets garbled and poof, the connection is gone.
So how in the world do you solve a problem that's literally baked into the laws of physics? Well, that brings us to the solution, and it is seriously brilliant. It's called timing advance.
The whole idea boils down to this one simple, elegant thought. You can't make the signal from the faraway phone travel any faster, but you can give it a head start. If you just tell it to send its message a tiny fraction of a second earlier, you can perfectly make up for that extra travel time. And that is exactly what timing advance is. It's a command, a direct order that the cell tower sends to your phone. It's basically saying, hey, you're a long way off. I need you to send your data precisely this many microseconds early. Got it? And the result? It's like a perfect photo finish at the racetrack. The signal from that faraway phone, because it got that little head start, crosses the finish line at the tower at the exact same instant as the signal from the phone right next door. No more signals talking over each other, just perfect, synchronized harmony. Okay, but that begs the question, right? How does the tower even know how much of a head start your phone needs? Well, that leads us to how they actually get in sync. The whole thing happens in two phases. First, there's an introduction, and then it's a non-stop conversation. So, when your phone first connects to a tower, it sends out a quick little hello signal. The tower knows exactly when it should have gotten that hello, so it just measures how late it actually was. Based on that delay, it sends back a first kind of rough timing adjustment, just to get your phone in the right ballpark. But this next part, this is where it gets really smart. As you move, let's say you're driving your car, your distance to the tower is changing all the time. So the tower never stops listening. It's constantly monitoring your signal and sending these tiny, non-stop correction commands to keep your timing perfectly tuned, microsecond by microsecond. It's an ongoing chat. And this table here lays it out perfectly. That initial sync is a big, one-time setup command when you first connect. But the continuous sync, that uses much smaller, quicker messages. They're just little nudges saying a little bit earlier or a little bit later. It's a system that's perfectly built for fine-tuning while you're on the move. Okay, so this is where this whole thing has a super unexpected and, frankly, kind of mind-blowing side effect. This system, designed just to stop signals from crashing into each other, also lets the network know almost exactly how far away you are. It's like a secret GPS.
78 meters. That number probably seems totally random, right? But believe it or not, that is the fundamental unit of measurement for this entire system.
So yeah, what is the deal with 78 meters? It's not just a random number. It all comes down to the math behind the speed of light and the specific way the network's timing system is built.
You see, those timing advance commands aren't infinitely precise. They work in these small, bite-sized steps. And the physics just works out that each single step of timing adjustment the tower tells your phone to make equals about 78 meters of round-trip travel distance for the signal.
So think about it. If the tower tells your phone to adjust its timing by just one step, it knows you're about 78 meters away.
If it says adjust by 2 steps, bingo, it knows you're 156 meters away. The network is literally using time as a measuring stick.
Here's a perfect example to lock it in. If your phone gets a timing advance command with a value of 10, the network knows that's a 10-step delay it needs to correct for. So it just does the simple math. 10 times 78, and boom! It knows you're roughly 780 meters away. Pretty cool, right?
Now, this whole system is incredibly reliable, but it is also absolutely critical. If that constant conversation of tiny timing adjustments breaks down for even a few seconds, the consequences are immediate, and they're severe. So let's just walk through what that chain reaction of failure looks like. First, if your phone stops getting those little correction commands, its timing starts to drift. Pretty soon, its signal starts stepping on other people's signals, creating that interference we talked about. The tower starts hearing gibberish it can't understand, and after a few seconds of this, a little timer inside your phone goes off and it just concludes, well, I'm out of sync.
And that very technical term, radio link failure, means one thing that we've all experienced: a dropped call. Your video stream freezes. Your download just stops. It's the digital cord being cut, all because a conversation that happens in microseconds went silent.
So, the next time you're on a call while driving down the highway, just remember this invisible race that's happening, this constant, high-speed negotiation just to keep you connected to a single tower. Which, it really leads to an even bigger question, doesn't it? What happens in today's networks when your phone is trying to talk to multiple towers all at the same time? Well, that's a whole other level of crazy coordination.